That's when you use quadratic formula. And when do you see those? Very rare.
Yahoo Mail.
Say again?
You have a work email.
Is it because of the decimal point?
Decimals, yeah. You could use complete in the square, but you'd be in the whips and chains doing it. I mean, it would be painful. All right, one last complete in the square. I'm going to make you work on this one. And that's about a 9. I'd quit. I wouldn't even try it. Too many fractions. Quit. I quit. What's the first thing you do? Move C. Good job. At least y'all can do that much, right? I'm going to start you off because I know some of y'all done quit. Now what? Factor out a negative 3/4. Now the way I tell students to do this is you're dividing, right? So just put an imaginary negative 3/4 right here. This thing doesn't like to do dots. I don't know why, but anyway. Act like you're dividing negative 3/4 here and negative 3/4 here. Okay? So when you get through, you've got a negative 3/4 out front. And then you've got x squared, because negative divided by negative is a positive. And then this is going to be negative. And then I'm going to go over here. I'm going to do 2/3 divided by negative 3/4. You don't have to divide by the negative. You got your negative out there. Let's not complicate things. So 3/4, that's multiplied by what? 4/3, which gives you 8 what? 8/9. So 8/9 x plus blank is equal to 6 plus negative 3/4 blank. All right? Now, do your next step. And what is your next step? B divided by 2 and square it. And I've shown you how to do a fraction. Write everything out. Two and the 8 will cancel. Leaves what? 4/9. And 4/9 squared is 16 over 81. Y'all supposed to tell me if that's right or not. Thank you. So now we have negative 3/4 x minus 4/9 quantity squared is equal to, well, that 3 will go in there 27 times. 27 and the 4 will go in there 4/27. Somebody help me out. Negative 4/27. (148 over 6). Somebody help me out. What's 148 over? No, 148. I don't know what I'm doing. Multiply 6 times. Okay, 6 times 27. What is it?
162.
Okay, 162 over 6. Is that right? Somebody help me out. What's 162 over 27? Is that right?
I don't even know what numbers you gave right now.
162 over 27. Somebody tell me what 162 over 27 is. Huh? Okay. I just got a common denominator. Yes, sir.
You know you got. You know how you got the negative at 8 over 9 right there?
Mm-hmm.
I thought you said when you have a negative on the outside, it's not going to affect what's in the parentheses.
When you factor it out, it does.
Okay.
When you factor it out. Not down here.
Okay.
Okay, but up here, when you factor it out, I'm not doing anything.
Where'd you get the negative 4?
Hold on a minute. This is bothering me, people. I hear a noise. Something's making this thing go crazy. Okay. What 4 where?
Up to negative 4 over 27. I'm not too sure how you get that. From the negative 3, 4.
Okay, down here. Four will go into 4 one time. 4 will go into 16 4 times. 3 will go into 3 one time. 3 will go into... Y'all know what kind of questions y'all are asking? What kind of questions are y'all asking mostly? Having to deal with what? Fractions. Why is that?
Because we use our calculator.
Huh?
We like to use our calculator.
Same reason the cash register person's head blows up when you give them 6 cents. Calculators. Calculators are good if you use them for what they're intended to. They're not intended for you to do fractions on. Fractions are 3rd, 4th grade things. That's why completing the square is so valuable. You do not have to depend on what? Calculator. You can do the whole thing without doing a calculator. All right, so who's got other questions? Come on, don't be shy. I won't embarrass you too bad.
So once you complete the square, and that 8/9 x is just gone, pretty much.
Yeah, pretty much. Talking about here?
Yeah.
Yeah.
Okay, yeah, I see
Oh, this,
Yeah.
the shortcut.
that. Yeah, then you take
The shortcut number 2, reduces this trinomial to a binomial squared.
Then you take the square root of 1600.
Yep. No pattern, no consistency whatsoever.
Click it and drag it.
I tried that. There is no pattern. There is no
What's that little thingy at the bottom of that thingy?
this.
Yeah.
That erases. That erases the whole page.
Okay.
I've tried. No
Or
pattern.
if you grab the corner of that box once it's up.
What?
Once you get that big box up, why don't you grab the corner of it and see if you can
It's
resize
gonna
it?
shrink it.
It's going to shrink the whole thing. Well, it won't work because of this stupid thing. It keeps going off. Oh. Okay. So I'll just erase the top of the board. I'm not going to try to memorize that. All right, -3/4 x minus 4/9 quantity squared is equal to, and what is 162 minus 4? 158? Or 27. I don't know where 4 came from. This thing is bothering me down here is what's the matter. 27. It's always Bush's fault. There's no pattern. I was going to see if I could delete it. I'm trying to figure out how to work it. I'm sorry.
See if you can copy the top one. That you just written out.
I'm trying. I can't. I wish they'd given us a class more than 30 minutes. Oh well, forget it. All right. So now the vertex, I'm just going to go ahead and write the vertex as 4/9. And negative 158 over 27. There's my vertex. Now I'm going to divide by 3/4, which multiplied by what? 4/3. That's going to give me x minus 4/9. Quantity squared is equal to
632.
Well, I was going to see if I could.
It doesn't.
It doesn't. So what is it?
632 over
632 over
81.
81. Okay. Go through and use my little eraser since I don't know how to delete. I tried Control X, that didn't work. And that's going to give me square root x minus 4/9 is equal to I square root of 632 over 9, and x is equal to I square root of 632 plus 4 over 9, which means no x-intercepts. What was our y-intercept?
Negative 6.
-6.
Yeah.
And this is 4/9, which is a half. And negative, what does this come out to be?
Yeah. Little under 6.
A little over 6?
Under. Because
A little under 6 because it's going down.
is 6.
Now make sure you know how to complete the square. Because if you can complete the square and do all of this stuff and find the domain, range, you know, the domain here is all real numbers. The range is negative infinity to 158/27. The increasing values is from negative infinity to 4/9. Decreasing value is from 4/9 to positive infinity. So, and if you can graph it, you can find the domain, the range, and do all of completing the square. That's a lot of algebra all in one problem.
I have a question.
Yes, sir.
How do you know there are no x-intercepts?
The negative right here. That negative right there tells you no x-intercepts. And that's covered in the video. We started that the first day, which y'all can pick up on the video. Question. How many completing the squares did we do? About 10 or 11? I don't know. I want to know, so I'll know how many of y'all on the test. Roundabout.
It's like 9.
I thought it was around 10. Okay. Well, that's 10 good problems. Now, how do you practice these? Well, make them up. You can make them up all day long. How do you check them? With your calculator. I don't have an on-board calculator. I got to get them put on. I don't know why IT took them off. But anyway, they took them off. Take your calculator. Everybody got the calculator? Now you can go to Wabbit EMU if you got an Android. I'll go ahead and tell you this right now. You got an Android, go to the Play Store and go to Wabbit EMU. You can download whatever calculator you want on your Android. Of course, iPhones, y'all way up here, we're poverty, we're down here in the project, so that's where the people are. You people with iPhones, you have to go through an act of Congress. I don't know, evidently y'all are too good, the iPhone is too good to have Wabbit EMU, but I don't know. I really don't know why they did let that. Let me just go show you. And you can get by without. I mean, if you got a Galaxy or an LG with a pretty big screen, it works out real good. If you got an old flip phone from the 70s, it ain't gonna work worth crap. But dang old pull up, dang old Rabbit. Yeah, calculator, emulator. So if you want to know more about it, go there or whatever. But anyway, you can pull up. I don't know why they took them off, but they did. You can make up any 2x squared plus 4x plus 3 and type that in on your calculator and draw a graph and see if it matches your graph. See if it matches your sketch. I'll do a worksheet for you, or I'll put some, when I do the WebAssign, I will, after I create the class on WebAssign, I will email all of you and tell you what to do and what to look for and all that stuff, okay? But I'm not going to worry about that right now. I'll do it this weekend. Now, let's talk about rationalization of denominators. Why do we do rationalization of denominators? Say again? You do not want square root or radicals on the bottom of the denominator. You do not want radicals in the denominator. Now, in Calculus 1 and 2, they do ask you to rationalize the numerator sometimes. Very rare. But you need to be able to rationalize both. Now, you do this because in limit theory, in limits, you actually have to get rid of the radical in the denominator. And that's why. That's why I need to show you how to do this. So, let's take something simple. 4 over the square root of 2. That's pretty simple. Now, I've got a radical in the denominator. So, I want to get rid of it. So, how do I get rid of it? I rationalize. I take the denominator and put it over itself and multiply through. What's the denominator? Square root of 2. So, I multiply by square root of 2 over square root of 2. And multiply through. And that's going to give you the square root of 4, which is 2 on the bottom. And 4 square root of 2 on the top. And that comes out to be 4 square root of 2 over 2, which is 2 square root of 2. And I've just gotten rid of the denominator, or the radical in the denominator. Mm-hmm. Yep. All right, let me throw a monkey wrench in it. So if I take your eraser and erase the little 3, and then you can do the problem, right? Or quit. Throw your pencil down with a little pop and quit. Which one's easiest? There you go. Quit. Now, this is a cube root. And it changes everything. You've got to think in terms of cubes. What is your first cube that has anything to do with 2? 8. So I got to multiply by the cube root of 4. Because what is the cube root of 2 times the cube root of 4? Cube root of 8.
Oh,
You're thinking in terms of squares. You got to think in terms of cubes. And what is the cube root of 8? Over 2. So the reason I showed you this one is just so when you do see a different index, you have to think in terms of that index. Question. Okay, on a scale from 1 to 10, it's about a 1. Let's bump it up a notch. Now, when dealing with a two-term denominator, you're going to use what's called the conjugate. When you see the word conjugate, what do you think of? Huh? Opposite. There's a butterfly on the top of this. Conjugate means the opposite operation, basically. I'm not going to give you the mathematical definition because you won't remember it. Opposite operation. So if I tell you 2 plus 3, what's the conjugate of 2 plus 3? 2 minus 3. If A plus B, the conjugate is A minus B. So multiply by the conjugate of the square root of x plus 3. That will be there. Square root of x minus 3. If I could learn how to write. Now, when you're using the conjugate, what will that always give you in the denominator?
0.
Will always give you shortcut number 3 in the denominator. These shortcuts are not going away. So if you're one of these people that went through algebra and did not learn the shortcuts because you wanted to use the FOIL method or the reverse FOIL method, then you better learn them because they're going to follow you all the way through Diffie Q. So I'm going to take this and I'm just going to change it to yellow. Square root of x minus 3. X minus 3. That's the. And on the bottom, I'll take my red marker. And what does that give you? the conjugate will always give you shortcut number 3 in the denominator. So plug it through, make it go through shortcut number 3, and see what you get in the denominator. For those of you that were not here, Three Musketeers. Shortcut number 3, to remind you, a squared minus b squared is equal to a plus b times a minus b. As I tell my algebra students, put that right up under the shortcut or the problem and do the math, do the algebra. And I'm going to do that for y'all, not because I think y'all are ignorant, but I know that some of you have not had algebra in a long time, so I'm going to do it for you. So I'm going to take this guy right here, and I'm going to put it right here. So what is A? Square root x. So I'm going to go down here, and I'm going to put parentheses squared minus parentheses squared. I don't care about the numerator. Numerator is the least of my worries right now. Because what is the objective? To get the denominator clean as far as a radical. Yes, you're right. So square root x. And then what's b? And up top you get 3 times the square root of x minus 3. That's all. We don't care about that. Now, question. What is the square root of x quantity squared? Ain't that nice? Hello? I'm ready to quit. That's your answer. Conjugate, conjugate, conjugate. Conjugate will always give you shortcut number 3. And if you know how to use shortcut number 3, it will pretty much do away with the radical.
Could you distribute that 3?
Yeah. But we don't care. Why? Because it's in the numerator. We don't care. I mean, you can. That's a possible answer. I would not mark it wrong if you did. It'd be 3 squared of 3 minus 9. 3 square root of x minus 9. And that's, you can't, there's nothing else you can do besides distribute. That's all.